Okay. We had a suicide attempt prediction machine learning model for ours. We used an existing data set to predict if somebody may be at risk of attempting suicide. We chose this because suicide and mental health are really prevalent issues in society right now, and we wanted to raise awareness about it and make sure that people had a resource in case they wanted to come and find out some more about it. We have a functional navigation bar at the top where you can go to the different sections of the project. And we also have a link to the GitHub and a try yourself page, which we'll expand on a little bit later. Here's the team. My name is Evan. I was our data janitor for the entire project.
Hi, everyone. My name is Maulika. I was responsible for visualizations and the coding.
Hello, I'm Rafail. I was responsible for the XGBoost. However, in the end, XGBoost disappointed me.
Hi, I'm Sophia. I did the KNN model.
Hi, my name is Arrisa. I was responsible for Logistic Regression.
And we also had Uzair, the best camp director we could have asked for.
Okay, so the Suicide Awareness and Prevention Index basically determines how likely someone is to commit suicide based on their age, ethnicity, gender, and several other factors. The goal of this product is to help identify those who are at risk of attempting suicide so that it can be prevented earlier. When we first trained our data, we found that it was very unbalanced, with ones people who are likely to commit suicide exceeding zeros people who are not likely to commit suicide by around 200. To fix this issue, we used a technique called SMOTE, which generated synthetic samples for the minority class.
So to start with EDA graphs, firstly, we have bar graph that is related with income and age. We did this bar graph to see what's the average number of income, and from here we can see that it's from 20K to 29K. And the secondly, we have a violent chart which show between what age is the most people did want to make suicide. So from here we can see that it's between 18 and 25 mostly. And additionally, we can see the minimum and maximum. Minimum is 70 and maximum is 70 and minimum is 12.
The next graph that we have is a density plot. It visualizes the comparison between age and income. You can see from the graph that most of the people have zero income. And at the age of 26, the big purple line over there, the distribution of wealth is the highest because people start building their career during that time. The next graph that we have is the pie chart. Since most of our data was categorical, we decided to build a pie chart which divides the people who committed suicide based on their race. And for instance, we can see that most of the people who committed suicide were white non-Hispanics, and the second majority was of Asians.
With our bar graph comparing virginity and friends, we were able to determine those who are virgin had more friends than those who are non-virgins. For example, comparing those who say they have the biggest amount of friends between both groups, a person who was a virgin said they had 600 friends, while a person who was not a virgin said they had 400 friends.
Okay, next we have the projects that we did. I was in charge of the random forest classifier, and what it is a bunch of trees in a forest. They all have branches and leaves that they have nodes of them. It's kind of like in a choose your own adventure book, how you just choose different paths until you eventually end up at an end result. That end result, each of the trees will collaborate with each other to figure out what the best result is. It's kind of like if you have a group of people and one of them knows a lot about cars and there's some questions about cars being asked, you'd probably go with what they say because they have more knowledge about it, or you would just go with whoever seems most credible, or you would come up with the best consensus as a group. That allows the random forest set classifier to be more accurate than any individual tree could. For the classifier, it was very good at determining true negatives. It did a pretty good job for true positives, and it has a relatively low rate for false positives and false negatives. And the true negatives had a precision of 0.08, the recall of 0.03, and an F1 score of 0.81. True positives had a precision of 0.43, recall 0.39, and F1 score of 0.41. The model did very well, although it was definitely far from perfect.
The next that we have is SVC, which is a support vector classifier. Our project falls under the classification category because we'll be able to classify data into two discrete things, that if a person will commit suicide or not. So we use this model. However, as you can see, it had a low accuracy of 0.49 compared to other models. The confusion matrix, however, was able to predict the number of true positives and true negatives a little better.
So talking about XGBoost, XGBoost is an optimized disturbed gradient boosting library designed to be highly efficient, flexible, and portable. And additionally, if you want to read about it more, you can see from the XGBoost link. I put a dictionary to there. And moreover, in the second picture, you can see the confusing metrics. It's disappointed because the accuracy wasn't well good as the others. Because as you can see from the confusing metrics, the false negatives are higher than the actual true positives. And the F1 score was for the people who are going to do suicide or who are risky to the suicide is 0.21, and who are not going to the suicide is 0.81.
The Knearest Neighbor algorithm basically estimates how likely a person is to commit suicide based on the 7 nearest neighbors or data points. The model has an accuracy of 0.59, and the confusion matrix shows a lot of true negatives, but not a lot of true positives.
Logistic regression was used to estimate a probability of an event occurring using a dataset with independent variables. With this model, we were able to predict an individual's possible attempt to suicide. This model predicted that 8 out of 15 people who stated they wanted to commit suicide committed suicide after completing the survey. This model was able to predict a higher true positive compared to other models, therefore a higher accuracy of 92%. With this, we can immediately find those who are at risk of suicide and stop them from committing it.
This bar graph that we have here perfectly represents the accuracies and F1 scores of all the models that we represented above. The purple line is the F1 score of true negatives, the green is the F1 score of true positives, and the red is the accuracy. Random forest, as you can see, has the highest accuracy, and logistic regression has better true positive prediction. Thus, our project has pretty good accuracy in predicting whether a person will commit suicide or not.
All right, next we have the try it yourself. So what happens is when you hit this, you'll be linked to this HTML page. And what it does is we have different input forms here, and you put in 1s and 0s and 2s and 3s depending on the value that you're going to put in. Because we have these label encoded, but we don't have the label encoded, the translations here. So for example, for gender, you have like 1 or 0 for male or female. Race has like 0 is white non-Hispanic, 1 could be black. There's different values and they're all corresponding to a number. We don't have that put up here yet, but we do have those values. So what you can do is you can just put in some numbers here. Let's just this, and it'll give you back a result of you are safe or you're at risk. And it's really neat here. I'll show you. So if you are possibly in need of help, we also have the number for the suicide prevention hotline. It's for the US. So we have that here as a resource for somebody that might need it. And if you put in these numbers, and it turns out that you're probably going to be fine, then what happens is you get this, that you're safe. And also obligatory from Rafail.
Of course.
All right, does anyone have any questions or anything about the project or the site?